there may be a slight buffering as it starts streaming to YouTube. We had that in the first session. So I'll just wait for the feed to kick in on the public page. Okay, I think that's up and running. So let's begin. Welcome back, everybody, if you were with us before, and hi to everybody if you're just joining us. This is the second part, so the third session of the EnteroBase Training Day. In this session, we're going to be covering the API includes tasks like downloading data from EnteroBase programmatically using scripts. I will say that this section will require a basic understanding of what an HTTP request is, what EnteroBase is, what the different schemes are. Need to know a specific language, like say you don't need an intense knowledge of Python to follow along, but you do need to have basic understanding of some sort of programming to be able to follow the examples. So let's get started. All of the documentation for the previous session and this session are up on the EnteroBase wiki, which is the page you're seeing in front of you right now on the feed. The address is simply bitbucket.org/enterobase/enterobase-web/wiki. You can actually just look it up as well on Google EnteroBase Bitbucket Wiki, it'll show up. So that includes all of the information about what Martin was covering and what I'll be covering today. All of the course materials is up on there. Some people were asking me, do you need an API token? You don't need an API token for this session. You'll be able to play around with the API a little bit in our sandbox without really having it set up. I do recommend, but you do need, for your general use of it, you do need an API token. So we'll cover the usage notes of how we want people to interact with the service. The full terms and conditions of EnteroBase available on the wiki page as well. So that's here. The most this is implied when you start using EnteroBase. It's fairly straightforward stuff. Probably interests most people is the specifics, which is at the bottom, called Appendix A, which are the things that you can or cannot do with the data presented in EnteroBase, and a number of caveats. So one of the ones that came up in the last session, which I'll repeat again, important, is that EnteroBase aims to serve genomic data to improve access to the scientific community. And we hope that this will lead to collaborations between data submitters and third parties. But the data remains the property of the data submitter, not EnteroBase. And if the usage is beyond what EnteroBase is displaying, it should be checked with the original institution that submitted the data. So I just thought I'd repeat that because that did came up in the last session. All right. So in terms of the API itself, the usage is, and all API requests need to be authenticated with a valid API token. And we will go through how to set this up and how to get a token. At the moment, it's not a free and open service that people can just use like you would with other APIs. At the moment, it's still sort of in a beta state. And this may or may not be relaxed in the future, but this is what we're doing for now. Secondly, this API, we wrote it so that people would use it. If you on how to make it more useful or how to make it fit into your workflow, please let us know via email or posting an issue on the Bitbucket page, and we'll try to incorporate that in if it makes sense. I'm sorry, we're getting some ones. I'll just turn that off. Mark's video is giving a mic feedback. Please be responsible in using the API. Try not to flood the server with requests. Add a 1 to 2 second pause between large chunks of data that you're retrieving, for instance. Don't try to submit large, long-running requests. So don't ask for every allele sequence in the database in one go. It won't work. It'll just time out, and you just basically waste your own time trying to fetch that sort of data. Just retrieve the data that you need. I'll show you the best ways to get to exactly what you want and do it really fast as we go through the material today. Try to download all the assembly data. Especially don't try to do this through the main REST API that I'll show you, because you can do it that way, and the intention of that particular component of the main API that I'll be showing today is for rapid live updates of small amounts of data. It's not designed for large-scale dumps of the entire database. So you have to consider now there are over 80,000 Salmonella genomes in EnteroBase. So that is a terabyte of disk space that it occupies at the moment. And trying to pull that in to HTTP requests, page by page, stepping through the database that way, would take you a very, very long time and would just put service strain for no reason. There are more efficient and more appropriate ways of interacting with the service, and I will be showing you examples of how to do that. We do not, this was a question that someone posed to me last night. They wanted to have a look at short reads. We do not store any short read data in EnteroBase that is already publicly available on NCBI, EBI, or DDBJ. So if you want a particular genome, you have to fetch it through those services as you would normally. User reads that are uploaded to us by a user directly into EnteroBase is stored in EnteroBase, but that is made publicly accessible to people. So people can't, so you basically can't, the long and short of it is you cannot download sequence reads to EnteroBase at all. You cannot retrieve RMLST, so we provide RMLST. We act as a mirror for the RMLST scheme that's developed by University of Oxford, and they've allowed us to use it, but they said that they don't want people to download the allele sequences or the profile. They don't want just a dump of the RMLST database. So that is not permitted to the service as well. So you can't do that. People who tend to abuse the system, if I find out about it, the first offense is I'll give you a warning. I'll try to help you understand what happened, and we can talk about it. The second offense, I won't be so understanding. Your API access will be revoked. And the third time, you're just making work for me, and I'll just ban you from the site. So that's enough of the boring housekeeping stuff. So let's actually jump straight into doing something. Let's start with getting this, because I think a few people might not have done that just yet. So the tokens are done on a case-by-case basis manually. So you actually have to first create a user account for me for yourself on EnteroBase. So it says, oh, it's still loading. Yeah. Yeah, so all of your activity has to be authenticated via HTTP basic authentication and with a valid token. Now, your token normally is if you just open the front page of EnteroBase, so that is EnteroBase. To go. The database homepage for any given database, then whether you have API access or not, and it'll write you the token. Yeah, So you click on that, and you've got it down here at the bottom. And this is what you pass as the username in your authentication header. Okay. Now, if you don't see this for a given database, it means you don't have access. And so then what you have to do is you have to email me. There's a template for people to fill out, which people generally do. We want to know who you are, where you're from, what you want to do with it, your username, because that's how I can find you on the system to give you permission. Okay. And so here is an example of how you could test your token using curl. So basically what you would do is you have the authorization header as basic. You enter your token here, which is that massive string from before, and you then do access a particular page on the website. So this one loads a particular genome in EnteroBase. Now this in Python, you can build it into a request, something like this. So this is a snippet, and I try in all of the snippets on the wiki use the standard libraries, standard Python libraries. This is a very, very simple task of just sending a request, HTTP request, and most other languages will have a module or something where you can do a similar thing. But I'm just showing you the example in Python. In this case, this is the same address we used with curl. And what you would do is you would just send a request by attaching the header. So you first have to encode the token as base64 string. Then you attach that string as the basic authentication, and you add that to the header, and then you give back the request, and then you submit that request with whatever sends it, and you'll get back a JSON object. Pretty much every single response you'll get from EnteroBase should be in JSON. It should be at least a string if it's an error, but usually should be a JSON format, which again, most languages have a simple way. In Python, it's something like JSON.load, operated like a dictionary, and then you don't have to worry about any specific thing with the API anymore. You can treat that as a normal object in your scripts. So the main important steps to remember is you send your request, the GET request, you have the token, and you've added that token to the authorization header, and you get the data back in JSON. Okay. Is any of that not clear so far? I'm not seeing any questions on YouTube. And is there any issues in the chat? Let's have a look. Nope. Okay. So I will continue on. Now, in the first example, I showed you this particular one. If you did esenterica / strain data assembly status equals assembled, and the limit is 1, it's just to grab one assembled genome out of EnteroBase, you get this back in JSON format. And most of the responses in EnteroBase have this particular structure. They have one part at the top that has links. So links, they have pagination. So if you've asked for say, if you've asked for, say, like in this case, then it'll give you a link that'll allow you to go to the next page. So it's like a web page, like you ask for 10, you ask for all of these records, and you say, I only want to see 10 in this, 10 per page. And then this gives you a link to the next page, and you can sort of walk up and down your results that way. You get the number of records on this page. In this case, it's 1 because I've only asked for 1, and it gives you a number of the total records. And then there's this chunk, which is normally named after the type of data that you're requesting. So we're using strain data, and I'll explain what strain data is in a moment. But what it has is that it has that as the header, and then nested within that is maybe an identifier, and then there's a bunch of metadata. So this is metadata about a particular strain. You see barcodes and other metadata like the date and the year that it was collected, whose strain it belongs to, some and other bits and pieces like that. I tried to add sample scripts for people at this particular repository, bitbucket /EnteroBase/EnteroBase-scripts. People come up with their own. I might incorporate that into there as well. And of course, the examples here on the wiki are up to date and they work as well. Let's see while we wait for that to load. Any questions? No. Okay. For people on the Hangouts, I've just sort of mute, so you'll have to actually tell me if you want to speak or not, because we were getting some feedback from before. All right. Automatic renewal of API tokens. Now, these tokens that you use to authenticate with will expire after about 6 months. Precaution so that if someone copies it or something, at least after some time it'll expire and people can't just keep using the same tokens. Whenever you go to the EnteroBase page, this is always new. So this is 6 months from this. And if you refresh it, you'll get a slightly different token because it's salted, but you'll get a slightly different one each time, but they're equivalent 6 months. But for people, they don't want to come, they want to have a script, they want to have something that works, and then they don't want to have to come back to the script and find that it's stopped working because the token expired. So what you can do is you can sort of program in the ability for it to do this stage where you basically log into EnteroBase and get this token back to the website. You can do it programmatically. Is accessible to this particular endpoint /API/version2/login, and then you pass it your username and password. I highly recommend that you do this through HTTPS so that your username and password aren't being sent in plain text. Secondly, I highly recommend that you don't use passwords on different sites. It seems obvious, but so don't have a password on EnteroBase that is you use for your internet banking. Just generally, that is not a good idea for any resource that you use. But anyway, so if you were going to take this endpoint and you were going to write it into, say, a Python script for you to fetch the token, so every time you use EnteroBase, or maybe once a day or every month, you have this sort of updating your token in your script, you would have the address, which is the same address up here, and you just pass it the username and password. You again send it, you can just send it as a normal request because you don't have a token to send. You're asking for the token. You just send it as a normal request to that address, and you'll get back a JSON object which has the token in it. All right, so let's actually do something more interesting. What's on this so far? Nope. Okay. It's fairly straightforward stuff at the moment. So let's actually talk about how data is structured in EnteroBase. So the API tends to follow the same sort of logical structure that you have for MNST and next generation sequencing data in general. So for instance, strains so be your sort of base object, and from that traces are derived or attached to a strain, and then from traces as in sequencing reads or short reads, and then attached to derived from traces are your assemblies. So one leads to the other. And again with MLS with genotyping data, loci, and then alleles are derived from loci, and then sequence types are derived from alleles. And so this is the sort of structure that we have, and I've got a sort of diagram of the different endpoints that you can access to the NPI of the different data types in EnteroBase with a little brief description of what each of them are. And there are also generic methods that I'll demonstrate, which allow you to just fetch bit of information that don't fit this framework. And then and these generic methods like info and lookup aren't database specific. I will show you these in the interactive demo, but I will highlight will be most useful to people. Most people will be interacting with strains. That just allows you to fetch strain metadata. Most people will be interacting with assemblies. This is basically the assembly information about a given strain. Most people will be interacting with probably with schemes, which just has information about a particular scheme. They'll be interacting with alleles. That's where the sequences for a given allele are stored. And they'll be interacting with STs, where that's the ST numbers, and that also includes the alleles attached to that ST profile as well in that view. Strain data is an interesting one. This is sort of like a composite of several different tables. So it merges strain, so host, geography, lab contacts. It merges assembly information, so the N50, the coverage, links to the FASTA contigs for the genome assemblies, and it has information about the STs derived from those assembly, and that is all in a single endpoint for you under called strain data. And I'll show you how to interact with strain data. But that's probably where most people would start when they start to play with the API. And then as they realize that they need a specific type of data, then they'll jump to these other endpoints. One of the things that I've been working on is to provide a interactive sandbox for people to practice with the API and sort of test out their queries before they put it into some sort of a larger script. So Swagger is an API framework that I use for the EnteroBase API. It provides you with some sort of interactive documentation that I'll be taking you through. And it'll show you all of the inputs, the outputs, and some of the response codes that you would expect. And the link for that is enterobase.warwick.ac.uk/API/v2.0/Swagger UI. It's not Swagger. It's Swagger UI, actually. So it's got this at the end. I'll change that. But I'll be showing you that in a second. Let's see, any questions? Okay, so I have one question. Is it possible to download the allele data from more than one strain using the API? So I mean the allele profiles. Yes, you can do that. Showing you exactly how to do that after I go through some of the more general aspects of the API. So stay tuned. All right. Where am I? So many windows. Okay. The other thing that you'll notice in EnteroBase when you start to play with the API is this field called barcode. A barcode is a unique identifier within EnteroBase. It is assigned to almost all types of data, and it is unique for all the databases across all the species and all the data types. It's a very, very simple structure. You'll see something like this: SAL_AA0019AA_ST. SAL means salmonella. It's telling you the database of which this record belongs to. The second part, AA0019AA, is actually a number. It's encoded as, some of the numbers are encoded as letters so that we can fit more digits within a particular character. It's sort of like a postcode for the UK, where they use alphabets as well as numerical. And the last part on the end of it is ST, which means sequence type. So here's a table of what these sort of values encode. So SAL is Salmonella, ESC is Escherichia, Yersinia is YER, Warwickzella is MOR, data type scheme is SC, loci is LO. The interesting one is strains. Strains you'll often see is sometimes it's usually doesn't have a barcode tag at all. Usually it's just the header part, just the database and the number. That's by default is pointing to a strain. All other data types will always have a tag at the end. Now, if you have these barcodes, like if you've been operating with the database with EnteroBase and you've been searching through it, a barcode really quickly by just shoving it into this endpoint, which is lookup and then you just give it the barcode as a parameter. Something that simple. And what this particular one is, this is the ST19 in Salmonella, and it is pointing to the MLST ST19 is the standard 7-gene MLST ST, which is for typhimurium. So if you do this request, you get back all the information about it. You get the ID, you get the locus, you get the allele numbers. So ROC is 10, DNA N is 7, and so on. You get the barcode back. You get, based on the ST, we use that information to predict the Seravar. So you also get that information if that's available as well. You get the number of strains in that ST that have a particular Seravar, and this is the breakdown. So in that ST, 7,372 are called typhimurium, and then others are called different things. You get the ST complex as well, which is the EVG number, other bits and pieces about like dates and such. Now what I'm showing you is you can play with this in the interactive documentation. So this link here, this page. And if you take this, the lookup example, because it's right here, say string, and you go to lookup, and you can just put the barcode in, try it out, and you can just practice any of the EnteroBase API endpoints. It gives you the version would be in curl to do what you just did. It gives you the request URL. It gives you what the response is going to be, and so on. So you can sort of manipulate it, sort of play around with different queries and see if they're giving you the expected result. So that's the end of that section. The other thing is if you wind up getting lost and you can't keep track of the various pages and endpoints in EnteroBase programmatically, that is at the top level, enterobase.org.ac.uk/API/v2.0, which is just there under info, and that gives you the links to all of these various pages, the suffixes for the different data types, and the database prefix. So everything that I just said on this page is actually available to the API itself. All right, so I will start. Any questions? Nope. Okay. All right. API. All right. So I think someone asked already about downloading assemblies and schemes, and I think a lot of people are going to just want to do that. So I'll show that first, and then I'll show you worked examples of just playing with the API at the end. So one thing we get asked is, how do I download assemblies? People just like the idea that EnteroBase has given them an assembly, and they put their reads up, they have the assemblies there, and they want to fetch them back. Okay, fine. What you can do is, so I was talking about this particular endpoint called strain data. And this particular example is valid for, you're searching for, actually, I'll show you in the interactive one. Go to the interactive page, strain data. All right, so this is how I would recommend someone would go to and download assemblies for their data, or from a particular project or something. So let's say we want all of the Agona, Cerevar Agonas, Salmonella Cerevar Agonas in EnteroBase. So we say we want those. I'll keep that for a second. And that's it, really. And the database we want it from is from Enterica. And we want only the genomes that have been assembled correctly. So the assembly status field would be assembled. So we'll try that out. And we get this back. So here are a bunch of records. And it gives you all the information for it, so that you can pick out whatever you want. You have all the ST designations in here for all the various schemes, and all of that is within the single entry point. So we know pretty much 90% of what EnteroBase knows about this particular strain is available right here. Okay, that's fine. So first we kind of play with this and we say, okay, fine, this is the data we want. And we just want to start anytime there's a new Agona, I just want to fetch it. I'm going to introduce you to a field that's a rather interesting feature that's in most of the tables in EnteroBase. It's this parameter called only fields, which, as you can guess, only retrieves the fields that you specify. So in this case, you give it the strain name, you give it the download faster link. Now, if you look at the response, the download faster link points to another part of EnteroBase that allows you to download the contigs for that particular record. So if you do this again with that only fields, it's much faster for one. And secondly, you just get back the faster link and the barcode and the strain name. So in the example that I give you in, there's some questions. I'll follow that up in a second. So in the example I give you on this page about downloading assemblies, I've discussed all of this already. So in this script, again, we're back using a Python script. Simple script, it just makes a directory temp. It has this address, given these parameters that I've just shoved at the top here as globals. Serotype Agona database, Enterica, this is the server, this is my token, and I feed that into my address. And then I send that as a request to the API using this line here. I get back a JSON object, and then I can iterate through each of them. I do a second request on this download faster link, and then I write a file. So I've opened a new file here in the temp folder. I've named it the strain name that I fetched to the API, and then I just write that blob of text. It comes back as a string. So I just write that directly as text into the file, and then I have the assembly. And this is the same as downloading, as if you were downloading it to the web page. Okay. Anything else to cover on that? Oh, we got some chats and so on. Chat. Now, the API page doesn't look the same as you show. I've added a screenshot, but I can't add a screenshot. Only comes up as text. The API page, which API page? You mean this part, the actual documentation, or you mean this interactive component? Please just add a comment. Oh, okay. Yeah. All right. So add hyphen UI to the end of that, and it'll come up. It won't be text anymore. So I will post that in the comments for you. And I'll post that on the chat as well, so everyone can follow that. That should be the version. Okay. Some other questions. Allele profiles, yeah, we're going to come to that next. Is there a follow-up on the issue in Bitbucket? Alleles are missing when all alleles are requested. Back and checked. I think all of the alleles should be up. I did amend that. I'm not sure. That should be done. But another question is, how can we know which are the possible values for query fields in strain data table? So the okay. How do you know what the when you're playing with it, it should give you an error if the value is incorrect. It won't sort of do any sort of, so if you're trying to nonsense in there, you'll just get back no like as if you've just done a bad web search into any of these fields. This particular one of only fields relates back to the parameters themselves, and the ones you see in the output in the response body section. Most of these metadata fields, it's pretty much metadata that you're putting back into it. It's not, I've tried to write little notes. Probably need to add a few more descriptors as well. Is there a controlled vocabulary reference, especially for metadata containing strain, collection, and source? So that's an interesting question. At the moment, we've spoken to a lot of organizations about trying to develop an ontology for describing a strain's host or source or other clinical data and metadata as such. Is an ongoing effort to try and put that together. And at the moment, those fields, such as if you're looking at things like host niche or host type or host details, we've tried to curate them at the beginning of the EnteroBase project as best we can. It's not done particularly well, and a lot of it is just verbatim what people put on in CBI. So we are at the mercy of what submitters and put up on NCBI, and it's not always as good as it should be. So no, there isn't a controlled vocabulary reference for vocabulary. If there was, please let me know. We'd love to implement it. Is it possible to easily download a representative of each ST type present in the database? I mean, easily, I'm assuming you mean is it one click? And one click would be, no, you can't do it in one click. What we do have on EnteroBase at the moment, we're starting to, which window am I in? Yeah, okay. We do have, this one would be quite useful for most people. Public, and it's called All RMLST. This might take a second, it's about 3,000 strains. Coming up in a second. Yeah. Nope. So the short answer for it, though, if it decides not to work for me right now, we are cases that have representatives that we've defined based on RMLST at the moment, but we could do one for 7-gene MLST that would give you the diversity of a particular species. Here we go. So these strains, this is a minimum spanning tree of a representative from each ribosomal MLST type for all of Salmonella, the entire genus. And this is there on a tree. And this particular one, you can sort of work with this sort of workspace of all of these, but these are manually curated, and we're trying to have these as public workspaces that people can jump to, because it would be a very useful feature to have. But and still do it programmatically to the API by essentially getting the downloading the ST information for a particular scheme for all of the strains, and then just picking the first one. But that would require like at least 2-3 requests and sort of iterating through it a couple of times. Is there global? So Florent asks, is there a lookup of what global values present in the database? No, that's an interesting point of what is sort of like the non-redundant list of values you'd expect for a given field. That's something I might actually, yeah, that's a good point. That's something we don't provide at the moment, but it would be worth implementing. Yeah, as Martin showed in his session, you do get this sort of auto correction suggestion box that sort of does give you a hint of the value that you're possibly looking for. But yeah, that's something that could be in the API as well. Yeah. All right. But we don't provide that at the moment, no. Let's see. Where am I? Hangouts. Any more questions? Okay, good. The UI page is working now. All right. All right, so where were we? So I think that's in terms of downloading assemblies. Now, downloading schemes. I think I'll close that one. It's just my internet slow, actually, for some reason. Because I'm streaming all the videos in the background as well. Here we go. All right. So this is one that people ask us a lot, is they just want to get the definitions or the reference sets of alleles and ST profiles for a given scheme in EnteroBase. I should remind, we don't provide RMLST. You'll have to go to University of Oxford for that. But the other one, so CGMLST, whole genome MLST, and the 7-gene MLST is all, you can all fetch it really easily to the API. Now, I did notice that some people who use the API have this, they see this page, and they see that they can sort of fetch information. So if you went to say STs and you look, let's say I want MLST Ackman, the 7-gene scheme in Esenterica, and I want ST19, can fetch it this way, but this is really slow because you're requesting over and over and over again. And even if you're quite clever with your requests, it just takes forever. So what we've been doing is we provide a daily dump of the entire database, so that what we would think an end user would be doing is they first initially grab the daily dump, whatever database they have or whatever they're doing, they would use that to start off with. And then I think with EnteroBase, they would then use the main API this way, send these sort of requests, just to catch up on what has changed in the last day or so. An example of what that kind of workflow would look like. Any questions before? No questions before we get going. So that's all written here in the wiki, essentially, the daily dump, and then keep polling for new stuff. So the first thing is like, what are the schemes that are available to me? And that's really simple. You just query the schemes table. So for given schemes, and you just poll it, and you get a list of all of the schemes back. And the one you're interested in is the download ST link. A download STS link gives you all of the allele profiles. And that link will almost never change. So if you're a bioinformatician who's only interested, you're in a reference lab and you only want to do 7-gene MLST, and for a given species, this link that I've highlighted, you can see my highlights, okay, good. Something like that never changes. You can just download the whole thing as a tarball, tar.gz file. And the same thing for CG MLST, whole genome MLST, and our second CG MLST version 2. we provide the first version of CGMLST, which was our beta version for sort of public record, but we would say that it's been pretty much superseded by version 2. So I would use this to get the CGMLST rather than the other one, and whole genome's up there as well. So you poll for the schemes, you fetch the tarball of the profiles from this download ST link. And this is sort of like an explanation of the different schemes. And this is an example of how you would do that in Python, of downloading the tarball. The one thing that I should add that people get stuck on sometimes is, at least in Python, you have to tell it it's a binary. I think in most languages, you'd have to tell it that this is a binary file. Otherwise, you're going to get a string file that has binary, the gzip like encoded in it. It won't make any sense, and it'll look corrupted. So it has to be, you're writing it as a binary file when you fetch it from that download link. But that's the only real danger with that. Otherwise, it's the same way as requesting any data in EnteroBase. Doing this, once you've got the links that you want, like this, they're never going to change. So you can just have a script that just does this, hard code it in, pull down the profiles, and then in this file, you're going to get the ST number and the allele numbers for each locus. And that's for the entire database. That's updated every day. Now, you're going to want also allele sequences as well. So the allele sequences you can fetch to this method, which is a similar method. But instead of going to schemes, which is where we went to get the ST profiles, we are going to go to loci. The loci endpoint is PI/v 2.0 / enterica for salmonella / mlst_acmin. So and / loci. I don't think you have to tell it the scheme again, but yeah. Basically, what you poll the loci endpoint for is you tell it the species, you're giving it the species, you're giving it the scheme, and you give it the and you get back all of the loci included in that scheme. So this is 7 gene MLST, so there's 7 records. It gives you a bit of information, and it gives you the download download alleles link. Now the download allele link is all of the allele sequences for that particular locus. So this one will give you all of ROC. We do not provide sense to have them in one file for small schemes like 7 gene MLST, but we found that it was very, very difficult to have this as a single tarball for something as large as whole genome MLST, which is 21,000 genes. And that as a sort of request is quite painful to just be waiting. Yeah, that became quite difficult. You started hitting timeouts and things like that. So we give it on a locus by locus basis, just to be consistent. And consistency is important for writing these sort of scripts, because if it's the same consistent thing, you can just dump the same script, can just with changing the scheme name can dump the 7 gene MLST and whole genome MLST and core genome MLST. And you'll have to do some cleaning up in terms of merging them into whatever data structure you want to do with all of those allele sequences. But once you have that set up, so you've got, between the two, you've got everything that we have for that day. And then you want to keep it in sync with as things change. Trick is when you send a request, as you would for just general searching in EnteroBase, you use a specific value, a specific parameter called rel date or relative date, which is here. So you just pass, so that number, so here rel date equals, so in this particular case, we want all of the sequences from 7 gene MLST, ROC, and Salmonella in the last 20 days. Right, so we haven't updated our data set in the last 20 days. We want to what's happened in the last 20 days for this locus. So that in the last 20 days parameter is rel date equals 20. And the same thing applies. You use the exact same thing for STs as well. You just say STs, and the scheme is, you give the scheme and you give the and you say rel date equals 20. That's just to add a bit for the synchronization. And if you do something like that for this ST, I think it's STs in the last 20 days, and I did this last night. You can see these have been added in the last 20 days. So ST7 3767, for instance, and there's a list of all of them. There's been 33 in the last 20 days have been added to the old 7-gene MNST scheme. So if you had this, and this is updated, you can pull this probably every couple of hours or something just to keep in sync with EnteroBase. And so between getting the blob, the big block of all of the schemes initially, and then continuously polling to keep in sync, you can be pretty much in step with what we're doing. So that was a lot of content. Let's see if anyone has got any questions. Any questions at all? I'll wait a minute for people to ask. No? Okay. If you have any questions and you're embarrassed about me reading them out, answering them or something, you can email me privately and we can talk or whatever. Not that I'm actually singling anyone out. Let's see. No, okay. I'm guessing either everyone's going to sleep talking about JSON strings, or I'm just really good at explaining stuff. I'm assuming the former. So that is the bulk of the content that will get you pretty much 80% of where you want to go in EnteroBase based on what people have been talking to me about. I will show a few examples of some interesting ways of fetching data and interacting with the API using the interactive documentation. But smart cookies among us would probably already be playing with that and sort of breaking it and doing all sorts of things. Let's see. All right. So what is... Any questions? No? Let's see, which was the example I wanted to cover. So I've covered barcodes. Wheels. Oh, let's see. Oh, I got an email, but I thought it was from one of us, but it's just junk mail. Yeah. So I'll reiterate the important is the rel date. So I've shown that example as well. Oh, one other thing I should mention actually, now that I remember it, is fields like constraints. So in the strains field, you can usually, if an obvious thing is you want more than one value for a field. So you don't want to just look up Cerevar agona for Salmonella. You want like 3 different Cerevars, for instance. That is easily achieved by adding a list. So agona, comma, typhi, comma, what's one of, yeah. So if we put those 2 together, then, oh, we need to, that's in Esoterica. No records? I think I might have put a dot instead of a. All right, that's misbehaving. Oh, it's working last night. Oh well. In principle, yeah, I'll fix that. But yeah, in principle, you can just pass. Oh, that's county, not country. In principle, you can just pass a comma delimited list to the value and to a parameter, and you'll get back a mix of those. I might actually be hitting a timeout. That's why I'm not getting a response. Yeah. And that's, yeah, so same thing I demonstrated that though with only fields that you give a comma delimited list for that. The other thing to keep in mind is you do get the pagination with the links component in your response. So if I just ask for a page, the links here for the next set of data, which is fine. But if you want to manually sort of jump around, you can pass an offset value, the offset equals 1000 to jump to the thousands in the search results if you wanted to. You can also order by any of the fields, order fields, so order by barcode by default, but that could be order by country, order by strain name, or whatever you want to do. And the limit, yeah. So that you can play around with the limit in terms of response time. Usually I recommend not bumping it more than about 300 a page for strain data, because strain data is actually giving you three tables worth of data back. So you're querying, and the strains table itself, so just a single table like strains or alleles or loci, you can ask for maybe 1,000 at a time, just as a guideline of what sort of tends to work as the fastest. Any other questions from people? Here we go. Can we use the time tag to sync the sequence files of loci? All right, I might need more clarification, so expand on that question if I don't quite get it. The window again. So we don't, every time we do the daily dump, it's updated on our server. So we don't keep a back catalog of every single day. We don't archive it. It's prohibitively expensive, especially with whole genome MLST, which works out to be about 0.5 GB. So even after 10 days, it just takes too much disk space. So we only keep one copy. So you can't just grab a static dump of, say, what was the database 30 days ago or 3 months ago. That you would have to sort of take the dump that's there and then filter out all of the records that have been added since using the API. Yeah. I'm not sure if there's a sensible way we can store and serve that information without a lot of work. And I'm not sure if people want that. If you sort of ability to recall a state of the database at any time, please get in touch. We do keep timestamps for all of the records to the API, but just having a sort of blob like that, we don't do. Okay, I think we can adjourn it. That's another hour and a half. No, that's just 1 hour anyway, and we pretty much covered all the content. I do recommend even around with the interactive model. I might contact the commenter who said, how do I get a catalog of all the possible values, since all of the fields are here, but I don't give you a catalog of all the values. I'd be interested how that would be, how I could serve that. So I might ask you for a bit more details of how you'd like to see that being presented. But otherwise, yeah. So thanks to everyone for attending. I didn't get to see as many lovely faces as the last session. Yeah, so thanks everyone for attending. I will be sending out a follow-up email asking for some feedback of how you thought the training sessions went and how you think about EnteroBase generally, and what do you think we can improve, features that you are missing. Yeah, so thanks for attendance, and please let me know if you have any problems with the interacting with the API. And if you are trying to get hold of really large chunks of data, please talk to us about it, because then we can actually ask the way to do it, or at least just something new to help you get your work done faster. Oh, one more question. Can we edit the metadata using the API? Not at the moment. At the moment, we're just trying to get, the biggest request that I get is, I want to just download your data. I want to interact. I just want to pull everything out of EnteroBase at the moment. And that is really what we're focusing on. If a lot of people want edit metadata through the API, we can do that next. But at the moment, no, you can't. You still have to go to the website to do that. But as Martin showed, editing metadata can be done fairly easy by modifying the records in a tab delimited in a tab delimited file, and then you can upload that to the web page pretty easily. So you can do bulk changes pretty fast on the website itself. All right, well, cheers, guys. By email, and thanks for your interest in EnteroBase.